So in 4.3, we're going to look at some basic relationships of probability. And one of the ways that we're going to do this is by using a Venn diagram. So a Venn diagram, you'll have a rectangle, and everything in the rectangle belongs to your sample space. Okay, everything in the rectangle belongs to your sample space. Now what we can do is say that, you know, maybe something over here happens. Okay, so that's going to be event A. So that's what we're going to talk about. So what's the probability of event A happening? So what we could say is our sample space could be everybody enrolled at a specific university. And then the my event right here that we're going to talk specifically about is those enrolled in statistics. Okay, so this could also be those enrolled in English, those enrolled in whatever. Okay, but my sample space would be all the students, and then my specific event is going to be those enrolled in statistics in this particular case. Now, we're going to note that as the probability of event A. So the probability of event A is going to be found by what we talked about in the last section. How many are in here versus how many are actually in the entire university. So we could use nice pretty numbers and say, you know, there's 20 people enrolled in statistics out of an enrollment of 1,000 in the university. So 20 over 1,000 reduces to 2 over 100, which is 2%. So 2% or 0.02, okay? So remember, move it twice by multiplying by 100. So that gives me 2%. So my probability is 0.02 or 2% that a student that I grab at random from this university is enrolled in statistics. Now, let's do another thing. The complement of this is going to be A with a little c up there. So that's essentially the probability that this isn't happening. In other words, there are 1,000 students. Let's talk about the ones that are not enrolled in statistics. So the complement is going to be the other portion. So in my case, we have the ones that are enrolled in statistics. The complement would be the ones that are not enrolled in statistics. So if that's going to give me a probability of 0.02, then the probability that I grab a student's, or the complement of this event, would be 0.98 or 98%. Okay, so now we can make this even more exciting. And we can talk about something else happening. So now we've got event B. So this is event A, and then I've got event B. And notice that there's an overlap in there. Those are things that they have in common. So let's go back to our student enrollment. This is still all the students in the university. These ones are still the ones enrolled in statistics, but let's just say these are ones enrolled in English. So the ones that are in here are the ones that are enrolled in both statistics and English. Okay, so this is just statistics, this is just English, but the ones in the overlap are enrolled in both courses. Okay, so that's how we're going to read this Venn diagram. So we want to look at some notation on how we do this. So again, we've talked about the sample space, we've talked about event A, we've talked about event B, or sorry, the complement of event A. And now we're talking about two events at the same time. So one of the things that we want to look at is the union. Okay, so I can say that this is A and this is B. So the probability of A union B, the way I interpret that, this is not a U. If you look at the software, it's going to be almost like a little boxy thing. And it'll look like that, but it looks suspiciously like a U. So that's going to be union. And that means I can have everything in A, everything in B, everything in the middle, but I'm okay with getting any of the three options. Okay, so the way I read this is the probability of A union B means the probability of getting A or the probability of getting B, or the probability of getting this little inside part, which is called the intersection. Okay, So this is probability of A, probability of B, or the probability of getting something that's in that middle part. Okay, so how do we figure this out? And I intentionally have not finished writing this thing. So the way that we figure this out is by using what's called the addition law. So the addition law is going to be, you can't see, the addition law is simply going to reference the union of two events. So the probability of A union B is going to be the probability of A. Okay, so the probability of students being enrolled in statistics plus the probability of B, which will be the students that are enrolled in just English. But then I got to subtract something off. Okay, I've got to subtract off the probability of A intersect B. So notice that looks like a little N. So intersection looks like an N, and that's the overlap here. So what we're effectively doing by subtracting off this part right here is we're saying everything in A plus everything in B, but that little overlap includes the stuff in A and includes the stuff in B. So we've got to take out the stuff from the overlap. Okay? So all you're doing is taking everything in A, which includes in the overlap, plus everything in B, which includes in the overlap. And then we're going to subtract off the overlap, so we're not counting stuff twice. Okay? So the little U thing means union, and the word that you're going to think of when you see the U or union is you're going to think or. Okay? I'm okay with everything. Everything in those two bubbles. So I can grab it from here, or I can grab it from here. I'm okay with both. Okay? Or I can grab it from the middle part. But the addition law that we're going to use is the probability of A, so the first bubble, plus the probability of B, which is the second bubble, and everything in them, and then take off what they share. And so that I'm not counting it twice. Okay? So this symbol looks like an upside down U, which looks suspiciously like an N. And we call that intersection. And when you see the word intersection, you're going to think of and. Okay? When you think of intersection, you're going to think of and. So a way to keep that straight is or starts with a vowel and U is a vowel. N kind of sounds like and. Okay? Or it also has an N in it. Okay, so that's how we're going to think of it. So anything here that's in this shaded part that they share, the overlap, would have to be true for both of them. So that overlap part would be a student that's in statistics and in English. Okay, so your intersection means and it has usually a lower occurrence of the union, and that gets into all sorts of probability issues. But it has to be things that they share. Okay, so that's our addition law. I've got my notes on the side, making sure I do all this. Okay, so we've done the complement, we've done the Venn diagram, we've talked about union, we've talked about intersection, and we've talked about the addition law. So we want to talk about something that's mutually exclusive. Okay, so mutually exclusive means that there is nothing in common. Mutually exclusive means that there's nothing in common, which simply means there's no overlap. Okay, there is no overlap. So if I were to draw a Venn diagram of mutually exclusive events, there's my sample space, there's event A, and there's event B. There is no possibility for them to have anything in common. So you could think of, holy cow, you could think of dogs, okay? And you could think of what do they have in common with a corn kernel? Ice cream, okay? What do dogs have in common with ice cream? Nothing, okay? Ice cream's not alive. Dogs are. Dogs have feet, ice cream don't. Okay, there's nothing in common. There's no overlap. Okay, so mutually exclusive, you can actually modify this addition law because you don't need to subtract off what they have in common. There's nothing in common. So the addition law for mutually exclusive events, you just add up the probabilities. Okay, So the probability of A plus the probability of B, but since they don't have anything in common, you'd be subtracting 0. Okay, so mutually exclusive means that there's nothing in common in the sample space that we're dealing with. Now, you could have a brown dog and chocolate ice cream, and they're both brown, but we're not getting that in depth. Okay, so we're just taking the basics from there. Now, that is going to be section 4.3. And then we're going to hit 4.4 and 4.5, which gets a little bit more in depth. And then we're going to take those probabilities in chapter 5, and we're going to start applying them to statistical issues. So that is 4.3.